Hello, Brenna and Noah here.
And in this video, we are going to convert between decimals and percentages.
To understand how these decimal and percentage conversions work, it can help us to know what the word percent means. Percent means out of 100, or simply per 100. You can remind yourself that there are 100 cents in a dollar. So what if we had the example 37 with a percent symbol after, 37%? Well, then we could think of this quantity as 37 out of 100, or 37 hundredths, otherwise known as 0.37 in decimal form. Okay, so how can we remember this in more general cases? I am going to draw a diagram for us. I have a capital D on the left for decimal and a P on the right for percent. Note that these appear in alphabetical order. So we started off with a percent divided by 100, and what was the result of that? Well, we really moved our decimal point 2 places to the left. Can't see it in the percent form. It's invisible though. It's right after the 7, 37.0%. So how could we draw that on our diagram? I'm going to draw a double arc arrow going left from percent to decimal. So that decimal point moved 2 spaces to the left, which was really just a shortcut to divide by 100. Okay, so that's one direction. What if we had instead started with the decimal form? Well, we would just have to move the decimal point the other direction, 2 places to the right, so that it ends up after the 7 again. So going to draw a double arc arrow going to the right this time from decimal to percent. And that decimal place movement is really just a shortcut for multiplying by 100, because multiplication is the opposite of division. So now we can go both directions, and this is the rule that we'll use for the rest of the video.
Thank you so much, Brenna. So let's go ahead and take a look at a couple examples of converting percentages to decimals. The first one that we're going to look at is 25%. We recognize that it's a percentage because we see the percent sign, and that tells us if we're going to convert, we're going to go 2 places back in order to get our decimal. First, we need to recognize where is the decimal already when we're in percent form, and it's right here. If we have a whole number, the decimal is always to the right of the last digit. So if we apply our rule of moving back 2 places, we'll start with where the decimal is and go back once and then twice and get 0.25. When we have a decimal at the beginning of a number, we like to add a 0 on just to really make it very prominent that we have a decimal right there. So we see that 25% is equivalent to 0.25 in decimal form. Let's do another example. Let's take a look at 4.2%. Here, even though we have a decimal in the number, this is a percentage, and we know that, again, because we have a percent symbol. Again, we're going to convert from percentage to the other form, the decimal form. Again, we need to go back 2 places. So we identify the location of the decimal. We go back once, and then we want to go back again, but there's nothing before the 4. Whenever this happens, we're going to just go ahead and put a 0 as a placeholder and continue on our way, going back a second place and ending with 0.042 as our decimal, and then going ahead and adding a 0 in our ones place to really allow that decimal to be visible. So these are our 2 examples of going from percentage to decimal. And one thing that's a little tell at the end to know that we've done this correctly is that the decimal form always seems like it's smaller than the percent form. Remember, these are equivalent. This is 4.2%, and it is equal to 0.042. But the 4.2 in the percent version looks bigger than the 0.042 in the decimal version. And that's it. We're now going to go ahead and hand it back off to Brenna, and she's going to show us a couple of examples of going the other direction, decimal to percentage.
Thanks for those examples, Noah. Now we're going to reverse our process and convert some decimals to percents. Let's start with 0.05. There is no percent symbol there, so it must be in decimal form. So now we will look at decimal 2% in our diagram. We multiply by 100, but we can shortcut that by just moving the decimal point 2 places to the right this time. So right now we can see our decimal point right here. It's between those two zeros. So then it moves past the 0 and then past the 5. And that is where the new decimal point will go. So we can say 0.05 is equal to 5.0%, but 5 is a whole number, so we can just write 5%. Okay, there's one example, but let's do another one. What about 0.6? Again, there's no percentage symbol, so it must be a decimal. And just like before, we'll move our decimal point 2 places to the right. So if we move it once, it takes us just past the 6. Oh, but there's no digit there to move it one more place to the right, but that's okay. It happened in one of Noah's examples as well, and we just add a 0 there. And so now we can see visually that in percent form, so 0.6 is equivalent to 60%. 60.0%, but again, 60 is a whole number, so 60% is a perfectly fine way to write that. All right, so we've done 2 examples going the other direction. Now that we understand both ways to convert, we're going to mix it up and see some other interesting things that could happen.
So we're going to look at 2 more examples, one where we have a percentage that's less than 1 and one where we end up with a percentage that's greater than 100. For our first example, we're going to look at 0.7%. So while this looks like a decimal in that it's less than 1, it's still a percentage because we have the percent sign. And we're going to use the same rule that we had before. Our strategy's not changing at all. We have percentage, so we go back 2 places to convert it into a decimal. So we locate our decimal place where it is, we go back once, and then we add another 0 for a placeholder, go back again, and this is where our new decimal place is going to be. So we're going to say that this equals 0. And then we have 2 zeros, so 0.07 as a decimal. 0.7% is equivalent to 0.007.
Okay, so just to make sure I have this correctly, if we have a percent less than 1%, we have 2 zeros after the decimal point in decimal form?
If we have a number less than 1 as a percentage, it's always going to be at least 2 zeros.
Oh,
we could have
okay.
more. Yeah.
Okay, I think I've got this.
Yeah,
Cool.
okay.
Let's see if we can change it up again. What if I gave a number in decimal form larger than 1, something like 2.946? There's no percent symbol there, so it must be in decimal form, and we want to convert it to a percent. Our rule says multiply by 100, or really just shortcut that by moving the decimal point 2 places to the right this time. Right now I can see my decimal point just before the 9. 1 place to the right puts it after the 9, and then 1 more place to the right puts it just after the 4. So rewriting this as a percent, we can write 294. There's the new location of the decimal point. And then the 6, don't forget your percentage symbol. So 2.946 is equivalent to 294.6%. We absolutely can have percents that are larger than 100%. For example, if we're talking about quantities that double or triple over time. But really, the point of this was to show you 2 examples a bit unlike the ones that we have already done, so that you're well equipped to handle a variety of conversions.
Thanks everyone. We hope this video has been helpful.
Keep calm and math on.